8-5. Use properties of trapezoids and kites. By the end of today's lesson, we will be able to successfully use properties of trapezoids and kites. I would like you to pause the video and take a moment to copy down the definitions to all of these vocabulary terms. Okay, for the trapezoid, it means that it's a type of quadrilateral with exactly one pair of parallel sides. So I'm just going to quickly sketch a picture of a trapezoid right now. So the parallel sides would be the top and the bottom. The basis of a trapezoid refers to the parallel sides of a trapezoid. So this would be base 1, base 2, or vice versa. The base angles of a trapezoid has two pairs, and each pair shares a base as a side. So this would be considered one pair, and this would be considered the other pair. The legs of a trapezoid are the non-parallel sides of a trapezoid. So we're talking about this side and this side. And an isosceles trapezoid is a trapezoid with congruent legs, meaning these two legs are congruent. And the kite is a quadrilateral that has two pairs of consecutive congruent sides, but the opposite sides are not congruent. So just like the word itself, the kite it looks just like a typical kite that you will fly in the sky. So this will be congruent to this side, and this side will be congruent to this side, but the opposite sides are not congruent. Okay, and example 1, show that CDEF is a trapezoid. So we can first prove that DE is parallel to CF. So let's do that. The slope of DE will be 4 minus 3 and 4 minus 1, which makes 1/3. And the slope of CF would be 2 minus 0 and 6 minus 0, which is also 1/3. And then if you check the slopes of DC and EF, so DC will be 3 and EF will be -2/2, which makes -1. So these two sides are not parallel. So this must be a trapezoid. Okay, for part B, suppose the coordinates of point E are 7, 5. What type of quadrilateral is CDEF? Okay, so we change point E to 7, 5. And now let's check the slope of EF, which is 5 minus 2, 7 minus 6. 3, 1, which is 3. So the slope is the same as DC. So this will make this if this were 7F, this would become a parallelogram. Okay, theorem 8.14. If a trapezoid is isosceles, then each pair of the base angles is congruent. If trapezoid ABCD is isosceles, then we can say angle A is congruent to angle D, and angle C is congruent to angle B. There's a proof for this on my website, and I would like you to refer to it right now to see how it is proved. And I'm just gonna give you a little hint here that you will have to draw an auxiliary line that's parallel to the side BA to prove this theorem. And for theorem 8.15, if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So again, if angle A is congruent to angle D, or if angle B is congruent to angle C, then trapezoid ABCD is isosceles. Again, please take a moment and look at the proof on my website before you move on. In theorem 8.16, a trapezoid is isosceles if and only if its diagonals are congruent. So again, trapezoid ABCD is isosceles if and only if AC is congruent to BD. And since this is a biconditional statement, you need to prove the conditional, which is given to you on the website. And it's actually a quick proof where you can just use the SAS congruence postulate to prove this triangle congruent to this triangle, and to prove the diagonals congruent by CP/CTC. And I would like you to do the converse for extra credit points. Example 2. A shelf fitting into a cupboard in the corner of kitchen is an isosceles trapezoid. Find measure angle N, L, and M. Since the trapezoid is an isosceles, then measure angle N should also be 50 degrees. Since angle L and angle K are consecutive interior angles, then by the theorem of consecutive interior angles theorem, we know that angle L and angle K are supplementary, so angle L should be 130 degrees. And again, angle M should also take 130 degrees. So I'm just going to quickly write my answers here. Okay, now we're looking at the mid-segment theorem for trapezoids. And it states that the mid-segment of a trapezoid is parallel to each base. So MN here, it would be the mid-segment, and its length is half the sum of the lengths of the bases. So again, if segment MN is a mid-segment of trapezoid ABCD, then MN is parallel to AB, and MN is also parallel to DC, and MN is half the sum of AB plus CD. Well, I'm not going to summarize the proof here because it's actually pretty long. I would like you to pause the video and take a moment to preview the proof from my website. Example 3. In the diagram, segment MN is the mid-segment of trapezoid PQRS. Find MN. So I can let MN be X, and then we have enough information to solve for MN. And this would be 25, and 25 divided by 2 is 12.5 inches. Okay, now I'm going to quickly go over the last two theorems, and you're expected to preview the proof from my website after you finish this video. And theorem 8.18, if a quadrilateral is a kite, then its diagonals are perpendicular. So again, if quadrilateral ABCD is a kite, then we can say AC is perpendicular to BD. Again, you can use Chapter 4 methods of proving triangles congruent to prove this theorem. And for theorem 8.19, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. And in this picture here, we have quadrilateral ABCD as a kite, and BC is congruent to BA. Then angle A is congruent to angle C, and angle B is not congruent to angle D. So this angle B, they're not congruent, but angle C and A are. Example 4 here, we want to find measure angle T, and we have a kite as indicated, and this is a quadrilateral, so we can use measure angle T plus measure angle R plus 70 plus 88 and set it equal to 360 degrees because it's quadrilateral. And since by theorem 8.19, angle T must be congruent to angle R, so I can go ahead and double measure angle T. And then measure angle T, which also equals to measure angle R, should equal to 101 degrees.